In 11.2, we're going to talk about adding and subtracting radicals. So you want to think about radicals as like terms, okay, like a variable of its own. When the radical part is exactly the same, they are like terms. That's what we mean by like terms. So when they are like terms, you would just collect the coefficients and keep the radical part exactly the same, just like if you were collecting x's or y's. So let's look at this first example. So if I look at number 1, I have 4 square roots of 5 minus 7 square roots of 5 minus 8 square roots of 5. Well, notice the square root of 5 part is the same. They are the same, so they are like terms. So I know square root of 5 is my answer. Then I'm going to go back and collect my coefficients. 4 minus 7 is negative 3. Negative 3 minus 8 is negative 11. And that is my answer. Look at number 2. I want to get the radicals together that are the same. So this one is the square root of 6, this one's square root of 6. So I can combine this one and this one. Well, 8 plus 1 is 9 square roots of 6. So those two are taken care of. Now I can collect these two because they are the same. They both have square roots of 3. Negative 2 plus 4 gives me a positive 2, and I have square roots of 3. So I can leave my answer just like that. Now when I look at number 3, take a minute, write it down, and look at this. None of the radicals match, right? So I can't consider any of them like terms, but I could reduce some of these radicals, and maybe then there would be some like terms. So let's just take one at a time and reduce our radicals. So we know we have 2 square roots of 27. Well, we know 27 is 9 times 3. Well, what's square root of 9? It's a 3, so I can take a 3 out. So this becomes 6 square roots of 3. Over here, I have a plus 4 square roots of 3, so we're getting somewhere. Now these are like terms, but let's see what happens with this last one. So I have negative 3 square root of 12. Well, 12 is what? 4 times 3, perfect square times 3. Take out a 2. So if I multiply those, I get negative 6 square roots of 3. Look at that. Now I have like terms. Now I can combine all three. So these two will cancel out. And so my answer is 4 square roots of 3. So what was a big old mess reduced very nicely. Let's look at the next one. All right, cube roots this time. So we're going to need to, and the radicals are not the same. So let's clean these up and see if we can make sense out of these. So the cube root, 16 is 8 times 2, right? Well, hopefully you recall that 8 is 2 cubed, so that's 3 2's right there. And I can take that out, and that becomes 2 times 6 would be 12 cube roots of 2. Now what happens back here? Let's leave that minus 2 for just a second. 54 is going to be what? 9 times 6. Keep going. You can go 3 times 3 times 3 times 2, right? Here's a group of 3's. Those 3's can come out, so that would multiply this right here. So this would be minus 6. What's left over under the cube root is the square root of 2. So it now matches. Now we can collect these terms together because the radicals are the same. So 12 minus 6 is 6 cube roots of 2. Notice what's under the radical did not change. Let's look at 5. Cube roots again. So let's think about this. 27 is 3 times 3, 9 times 3 times x. This one, 8. Hopefully you know this by now. 2 times 2 times 2, x to the 4th. Well, let's take out what we can. If we could take out that 1, 3, we have the cube root of x, right? We can take out our 2's, and notice there's 4 x's in here. If I take out 3 of them as 1, that leaves 1 underneath. Now I look at what I have, and they are both cube roots of x, so I can combine like terms. Except 3 and 2x are really not like terms, are they? But what I can do is kind of like a GCF thing. Take out that cube root of x. It's going to look weird for a second. But if I divide it out of both terms, then I'll have 3 plus 2x, right? Now we wouldn't write it like this. You would write your answer with the radical in the back end. All right? So even though you get common or get your radicals the same, it may not allow you to combine. Because again, 3 and 2x are not like terms. Let's look at number 6. Cube roots. Okay, these look... All right, if I clean up this cube root, 16 is 8 times 2. So that's 2 times 2 times 2 times 2. A to the 5th. All right, so I can take out 3. So there's 2 cube roots. Oops, I need to leave space for that a, right? There's 5 a's in here, so I can take 1 left, and I'll have 2 left underneath, and I have 1, 2 underneath also. Now let's look at this. Well, this one looks good. We already have a like term here, so it's plus the cube root of 2a squared. Let's clean up this one. 54 is 6 times 9, which is 3 times 2 times 3 times 3. So there's 3's to come out. And I can't take out a squared, there's not 3 of them. So I have to leave underneath the radical that remaining 2 and the a squared. Now I lean back and look, I have the cube root of 2a squared on each of these, right? So theoretically I could combine them all, except here's the wild card. There's a 2a out here. This value right here, this 1, doesn't have an a with it, and this 3 doesn't have an a with it. So I could factor out that cube root of 2a squared. And when I do, what's left over, if I take that out of each term, I'll have 2a plus 1 plus 3, right? And then I can clean that up and make it 2a plus 4. Okay, so that's kind of complex, but you can do it. You totally do it. Let's look at the last one. What about this mess? Hot mess. All right, these are square roots of binomials, right? So what I want to do is I want to start this guy by considering GCF. What can I take out of both terms under each radical? So in this case, I can take a 9 out. That gives me x plus 2, right? And if it's the square root, so I know 9 is a perfect square, and I'm going to take a 3 out. And that leaves me with x plus 2 underneath. So over here, what can I factor out of both terms? Well, I can take 25 out, and that gives me x plus 2 under the radical. Then I know 25 is a perfect square, so I can take out 5. And then what's underneath, left over, is the square root of x plus 2. Okay, look, they're the same, right? These are the same, considered the same like terms, so I can combine them, okay? So my final answer is just going to be 8 times x, square root of x plus 2. So don't be afraid when you see something with a binomial. Take the GCF and leave the leftovers in the parentheses. And hopefully those leftovers will match up eventually. Good luck, and we'll see you in class.